Ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 3, Notes 3, which is talking about multiplying monomials. Okay, so to multiply monomials, there's a couple of things we have to talk about first. So there's going to be a lot of boxes. Make sure you get this stuff written down because it is important information for what we're doing moving forward. So first and foremost, a monomial is a number variable or the product of one or more variables. Monomials that are all real numbers are called constants. Now you learned a little bit about that at the beginning of this unit. We learned what a constant was. So you don't have to write these examples down unless you want to, but in this chart is a bunch of examples of different monomials. We have constants, which are a bunch of numbers, variables, which are really just letters, and then we can have the product of the two. So we could have 2x or 3xy, or you could have a product of a bunch of letters. As long as it's one term all being multiplied together, that is considered a monomial. Okay, so everything has to be multiplied. So with monomials, we have some rules of exponents. So stuff we need to apply in order to do operations on it. So first is called the product of powers. So the rule when you're doing the product of powers is you're adding exponents. So what does that look like? So if we have a to the 6 times a to the third, that's a product of powers. We're taking two monomials and we're multiplying them together. So we need to actually add those exponents. Okay, we need to add the exponents. So a to the 6th plus a to the third is going to give us a to the 9th as our solution. All we're doing there is adding those exponents. So let's take a look at these next ones. So let's take a look at a power of a power. So this is if we're raising an exponent to another exponent. So if we're raising an exponent to another exponent, we need to multiply exponents. So let's take a look at this one written out a little bit more. So this is what it would look like. We'd have 6a to the 6th squared. Now here's what students forget the most. Those coefficients, those numbers out front, always have an exponent of 1. If there's no exponent written, the exponent is 1. So we need to take this 2 and distribute it in. And we're going to multiply that by each of the exponents. So 6 to the 1 times 2 is 2. A to the 6 times 2 is 12. So then 6 squared is going to give us 36, and then a to the 12th. So that's how you can simplify using that power of power rule. Next, let's take a look at this zero power rule. So anything to the 0 power is going to equal 1. So it doesn't matter how long of a thing we have, as long as the entire parenthesis is raised to the 0 power, it equals 1. Okay, so let's say we had a whole bunch of stuff being multiplied within a parenthesis. As long as it's within the parenthesis and it's raised to 0 power, it's equal to 1. Now know that the 0 power only applies to the parenthesis that is inside of it. Couple of things. So how do we simplify a monomial? So the first thing we need to make sure is that each base appears exactly once. So we want to make sure that there's only one x, there's only one y, and it's raised to whatever exponent we need. Okay, we want to make sure there are no powers of powers. Okay, so we don't want to have 3 squared to the 4th power. We want to simplify that down. And last but not least, we also want to make sure that we've reduced all of our fractions. So that's what we're kind of looking for on each version. So let's go ahead and take a look at these. So here, we just need to combine. Here I see that each base appears more than once. So if there's no exponent, I like to go in and draw a 1 to remind myself that that exponent is 1, not 0. Okay, so if there's no exponent, the exponent is 1. So that 4 has nothing to be multiplied by, so that's going to stay the same. X to the first times x squared is just going to give me x to the third, because here we're multiplying like bases, so we're going to add exponents. Okay, last but not least, we have y to the third, and we're going to tack that on there. Taking a look at number 2, now we want to multiply number 2 out. So we're going to do 3 times 2, which is going to give us 6. So we're going to multiply the coefficients still. We're multiplying the coefficients and adding exponents. X squared times x to the 4th. There you're going to add the exponents. So when you add the exponents, you get x to the 6th. Now here, that doesn't have an exponent there, so we have y to the 1st. I always like to add in that 1 to remind myself it's there. Y to the 1st times y to the 8th, add those exponents, and you get y to the 9th. Take a look at number 3. Number 3 should take you all of 2 seconds. Anything raised to the 0 power is automatically going to be 1. So that's your answer for number 3. I want you guys to go ahead and try number 4 on your own. Let's take a look at number 5. So that's being raised to the second power. So I have 4 to the first and x to the first. And I want to multiply that 2 by each exponent, including the one on the 4. So everything in that parenthesis has an exponent, and we need to multiply each one. So 4 to the first, we're going to multiply 1 times 2, which is 2. X to the first, we're going to multiply 1 times 2, which is 2. Y squared, now we're going to multiply 2 times 2, which is 4. So this isn't fully simplified because we can simplify down that coefficient. Well, 4 squared is going to give us 16. So we have 16x squared y to the 4th. So that's your final answer for that one. I want you guys to go ahead and try number 6 on your own. Let's just look at simplifying some expressions now. So here I have 5x to the 7th times x to the 6th. Now if there's no coefficient, the coefficient is 1. So I'm going to multiply coefficients. 5 times 1 is 5. X to the 7th times x to the 6th. Well, you need to add those exponents. 7 plus 6 is 13. Okay? I want you guys to go ahead and try number 8 on your own. Let me give you some tips. First of all, you're going to multiply these coefficients out front. And then you're going to add the exponents of the a's together and then add the exponents of the b's together. Next, let's take a look at number 9. So this looks really intimidating, but it's actually not. Rules of orders of operations say that we have to simplify our exponents first. So I'm just going to focus on simplifying this part. So I'm going to go to the inside first. So I have negative 2y squared. So what I do is I have a 1, each of these to the first power. Well, I'm going to think about this logically. When I distribute that 2 in, I get negative 2, and I'm going to put that in parentheses, squared, and then y squared. Well, negative 2 squared is 4. So I have 4y squared. Now I want to continue to work my way outward. So now this right here is being raised to the third power. So I'm going to take and raise this to the third power. So this 4, again, has an exponent of 1. So I'm going to take the 3 and distribute it into each exponent, not each number. So 1 times 3 is 3. Y to the 2 times 3 is 6. Now notice that this isn't 4 times 3. This is 4 to the third power, which is 4 times 4 times 4. So that's going to give us 64 y to the 6th. Now, once we've done that, we're ready to multiply it by this guy right here. So we're going to take this and we're going to multiply it by 3x y to the 4th. So here's what I'm going to do. I'm going to multiply my coefficients. So I'm going to take 3 times 64, which is 192. Now there's no other base with x, so that's going to remain x or x to the first. You can write the 1 if you want to. Here I have y to the 4th times y to the 6th. Now I'm going to add those exponents, and that's going to give me y to the 10th. So this right here is your final answer for number 10, or 9, sorry. Let's take a look at number 10. So for number 10, again, we need to distribute in those exponents. So we're going to start by breaking down this piece right here. So I have negative 4b, and I'm going to take the inside exponent first. So I'm raising everything to the second power. Well, they each have an exponent of 1. So I have negative 4, and then I'm going to square that. And b, and I'm going to square that. Well, negative 4 squared, a negative number squared is always positive. So there I get 16b squared. So now I'm going to take that 16b squared and I'm going to square it again because of that exponent there. So then this 16 has a 1, so I end up with 16 squared. B to the 2 times 2 is 4. Well, 16 squared is going to give me 256, and that's b to the 4th. So I've simplified that second part down. We need to simplify the first part. So we have a fraction there. That's okay. I know fractions seem scary, but we can deal with it. So I simplified the second part. So I'm just kind of doing it in pieces. So now I'm going to simplify this 1/2 a squared b squared to the third power. So each part of the fraction, the 2 and the 1, have a little exponent of 1 that needs to be multiplied to the 3. So this needs to be multiplied by 3, so we have 1 to the third over 2 to the third, and then a to the 2 times 3 is 6, b to the 2 times 3 is 6. Well, 1 to the third is always going to be 1. You can multiply 1 by itself as many times as you want. It's still going to be 1. 2 to the third is going to give us 8, because that's 2 times 2 times 2. Then we have a to the 6th, b to the 6th. So this guy right here needs to be multiplied by that second term that we found. So now let's go ahead and multiply that out. So 1/8 times 256, well, that's the same as 256 divided by 8. That means the same thing. So when you divide those out, you end up with 32. Now, a has nothing to be added with because there's no a term in my second monomial. So this is going to stay a to the 6th. Now we need to multiply b to the 6th times b to the 4th. And when we do that, we add our exponents, so we get b to the 10th. So that right there is your final answer for number 10. Let's take a look at number 11. So it wants us to write the area of a square as one monomial. Well, the area of a square is length times width. So we're going to take 4ab and we're going to multiply it by 4ab. Now remember, each of these a's and b's have an exponent of 1 on it. So 4 times 4 is 16. A to the first times a to the first, you're going to add those exponents, so you get 2. That's why I draw those 1s there, so I remember to add them. B to the first times b to the first is going to give me b squared. So this right here is your final answer for number 11. Let's take a look at number 12. So now we want to find the area of this rectangle. Whoops. We want to find the area of this rectangle. So the area of a rectangle is length times width, and then we want to multiply that times 1/2. You could also write that as 1/2 base times height. That's how we typically see a triangle. Okay, so we need to simplify that out, okay? Here is my base, here is my height. So my area is equal to 1/2 times my base times my height. So now what I'm going to do is I'm going to multiply these two together first. Remember, if there's no exponent, I put in the exponent as 1. So I have my 1/2. 3 times 4, we're multiplying our coefficients. That gives us 12. A to the 4th times a to the 1st. We're going to add those exponents to get a to the 5th. Then b to the 1st times b to the 1st, or b to the 5th, I'm sorry. This one should be b to the 5th. B to the 1st times b to the 5th is going to give us b to the 6th. Last thing we need to do is distribute in this 1/2. Now because this is all multiplied, when we distribute it in, we're really only multiplying it by that 12. So we're taking 1/2 times 12, which is really just 12 divided by 2. So then we get that that is 6. And then a to the 5th, b to the 6th. So that monomial right there represents the area of a triangle. So that concludes your note video today. Please make sure you take the Schoology quiz once you're done. Thanks for listening.